Hello there, Mr. Sutton here, bringing you the Algebra 2 5.5 homework solutions on performing function operations. For this first problem, they want us to find f plus g and f minus g of x using these f and g functions, and then state the domain. And then they want us to evaluate both of those for the value of x given here, which is 16. So let's just do the formula for f plus g first. That's just taking the f and the g functions and adding them together, like so. Since these are both fourth roots of x, we can add them as like terms. So negative 5 plus 19 is going to give me 14, and then the fourth root of x. And for the domain on that one, since this is an even root, we can't have negative radicands, so we need to have x greater than or equal to 0 for that. And now plugging 16 into that, we've got the fourth root of 16, which is 2, times 14 gives me 28. Now let me do the same process, but with f minus g. So now we're doing negative 5 fourth root of x minus 19 fourth root of x. That adds up now to negative 24 fourth root of x. Same domain as before, because again we have that even root. Plugging 4 in this time, or 16 rather, we've got fourth root of 16 is still 2, nothing has changed, but we have to multiply that by negative 24 now, so that's negative 48. For this problem, we're trying to find f plus g and f minus g of these functions here, and we're going to get the domain and then plug negative 1 into those revised functions. So we'll do f plus g first. That's this first polynomial plus this second polynomial. And adding all this together, let me first start by just getting rid of those parentheses since we just have a positive 1 being distributed in both cases. So first parentheses goes away, no changes. Second parentheses also going away with 0 changes. Combining like terms now, we have negative 4x, actually negative 7x cubed is the highest term here. And then we have negative 4x squared and 9x squared adds up to 5x squared. And then 6x minus 5x is going to be 1x. And it looks like there's nothing else to combine. Great. So now let's get the domain out of this. Since this came from polynomials and is itself a polynomial, the domain is all real numbers. At this point, let's plug negative 1 into all that, which I could probably do without a calculator. So we've got negative 7 times, this will be negative 1, so that comes out to positive 7. Next, this is 5 times positive 1, which is plus 5, and this is still a negative 1 here. This is 12 minus 1, which is 11. All right, let me go back and do the same stuff, but with minus instead of plus there. So now we're subtracting those polynomials. First parentheses can still go away for free. The next one, though, I have to distribute this negative. So we'll have negative 9x squared plus 5x. And then combining those like terms, we still have a negative 7x cubed, but now we have a negative 13 for the x squareds, and this will be 11 for the x's. Same domain as before, it's still a polynomial, so still all real numbers. Plugging negative 1 in this time around, we have negative 7 times negative 1 is still 7. Negative 13 times 1 is negative 13, and then this last thing is going to be negative 11. So 7 minus 13 is negative 6, minus another 11 is negative 17. For this one, we are trying to figure out f times g of x and then f divided by g of x for the f and g functions listed here. We're going to find domains, and then we're going to plug 27, negative 27 into those. Let's do f times g first. So that's just 2x cubed times cube root of x. Before we multiply these for real, let's make this radical into x to the 1/3 power. That way we can just deal with exponent rules. And if I add these exponents together, I have, let's see, this is going to be 9/3 plus 1/3 is 10/3, so 2x to the 10/3. Now let's get the domain out of this. Since this is really a cube root, it has a domain of all real numbers. We can plug in negative zeros and positives to cube roots, so that's totally fine. And let's actually plug in negative 27 to that now. This is going to be 2 times the cube root of negative 27 raised to the 10th power. And I know the cube root of negative 27 is negative 3, so we have 2 times negative 3 to the 10th, but then I'm going to have to wuss out and go to Desmos and plug that in there. So we've got 2 times negative 3, raise that to the negative 10, or the positive 10 rather, and that is 118,098. Okay, let's turn it around now and do the division instead of multiplication of f and g. So f divided by g of x, now we've got 2x cubed divided by cube root of x, which again is 2x cubed over x to the 1/3. Now we've got 9/3 minus 1/3, which is 8/3, so 2x to the 8/3. This one's a little bit trickier for the domain. You might be thinking, well, this final answer is a cube root, just like this other one, so it should have the exact same domain. However, to get this, the original function here had an x in the denominator. So if you were to plug 0 into this x in the denominator in the original, that would have made this undefined. So we actually have to leave 0 out of the domain. So x not equal to 0 is the domain on this one. And then plugging in negative 27 just like we did before. So now we've got the cube root of negative 27 to the 8th power times 2. This is still negative 3 for that cube root, and I'm still going to go to Desmos to do the rest of it. So let me just go back, and I already did 2 times negative 3 to the 10th. Let me just replace that 10 with an 8, and now we just have 13,122. For this problem, we're doing f times and f divided by g for these two functions here, 4th power and 3 radical x. And then we're going to plug 4 in for x. We'll also figure out the domain while we're at it. So let's start with f times g. That's x to the 4th times 3 radical x. And to really do this well, I'm going to change this square root of x into an x to the 1/2 power. So adding the exponents together, we've got 8 halves plus 1/2 is 9 halves. We still have the 3 along for the ride as well. For the domain on this one, since we've got this square root going on, my x values have to be non-negative. So that means I have x greater than or equal to 0 because of that radical. And plugging in 4 for that, this is going to be 3 times the square root of 4 to the 9th power. So that's 3 times 2 to the 9th, which I'm going to plug into Desmos just to be on the safe side. So 3 rather, times 2 to the 9th comes out to 1,536. Now let's go and divide these two things instead of multiplying. So we've got x to the 4th over 3 radical x, or x to the 4th over 3x to the 1/2 again. And this time we've got 8 halves minus 1/2, so that's 7 halves. And we've got a 3 underneath all that. So we can call this 1/3 x to the 7 halves. For the domain on this one, we have that radical again. So again, we have to have x not negative. But also because we have an x in the denominator of the original, we have to have x not be 0 as well. We don't want to zero out that denominator and get undefined. So I'm going to make my domain x greater than 0. Not greater than or equal to, just strictly greater than. Now plugging 4 into that mess, we've got, let's see, this is the 4th root of, actually a 2nd root of 4 to the 7th power times 1/3. Square root of 4 is 2. 2 to the 7th, I happen to know, is 128. So this is 128 over 3. For this problem, they want us to use technology to do all the function operations on the f and the g given here around the x value of 5. So let me go to Desmos and enter these in. All right, so we've got f of x equals negative 2x exponent, and then we've got 1/3 for that power. Let's do another one. We've got g of x equals 5x to the 1/2. And now let me do f and g with 5 plugged in, adding, subtracting, multiplying, and dividing those. So we've got f of 5 plus g of 5 comes out to about 7.76. And now f of 5 minus g of 5. Let me just go back here and we'll replace that plus with a minus. That's negative 14.60. Next up, we have f of 5 times g of 5. So let me replace the minus with a times. and now that's negative 38.24. And finally, f of 5 divided by g of 5. For this one, I have to just make a fraction. So fraction f of 5 and then g of 5 in the denominator. And that comes out to negative 0.31. For this problem, for a mammal that weighs W grams, the volume of air breathed in and the volume of dead space, the portion of the lungs that doesn't have air, is modeled by the B and W functions here. The breathing rate of a mammal that weighs W grams can then be modeled by this R of W thing. That's a combination of these other functions with a little bit more thrown in. They want us to simplify R of W and then figure out R of W for 6.5, 300, and 70,000. So first order of business, let's simplify the R of W function. Now we know what B of W and D of W are. They are these two functions here. So let's just replace B of W with 0.007W and D of W with 0.002W, like so. And then we can combine these pretty easily to be 0.005W. All right, let's divide these as well. So we have 1.1 divided by 0.005. Let me go to Desmos for that. So 1.1 divided by 0.005 comes out to 220. And then if I do, let me just not ruin the surprise too early. If I do these W's combined, I have to subtract the exponents. And since I have a first power here, that's higher than the 0.734 up here. So my exponent, my positive exponent, goes in the denominator. So we've got 1 minus 0.734 gives me 0.266 for the exponent in the denominator. So that's a grand total of 220 over W to the 0.266. Now they want us to calculate this for 3 different values. So I'm actually going to put this in Desmos so I can just keep using it over and over again. So I have R of W equals fraction 220, and then we'll put in that denominator we've got W exponent button 0.266. All right, now let me find R of 6.5. So R of 6.5 comes out to 133.72, and that's going to be, let's see here, breaths per minute. That's our breathing rate, BPM. Now let's do R of 300. So just replace that with a 300 in there. And that is 48.3 breaths per minute. And then if this is a very heavy mammal apparently, 70,000 grams. I'm not actually sure how much that is in pounds, but we're not going to worry about it. So 70,000, and that only has 11.3 breaths per minute. Breathes very slowly. All right, so there we have it.